Okay, students, we are now on 6.3, Introduction to Logarithms. So we have already studied exponentials, guys. So logarithms is the inverse, okay, of exponential. We have a couple of rules here. First, this is very important. If we are written log, and then this is a base b of a, okay, that's how we read it. Log base b of a equals x. If and only if, when we write it in exponential, it's base b to the exponent x equals a. So in essence, guys, your log is going to have a base, okay? And log base, and then whatever the answer is, it goes right there. Equals, and then the other side will always be the exponent. I want you to think it as b to what exponent or what power equals to a. Let's try the first three examples. Example 1 to 3 says, write in logarithmic form. That means we're going from exponential form, 5 to the third power equals 125. So to write it in logarithmic form, we will start with the word log. And I want you guys to see this is your base 5. Your base is 5 in the exponential form. So that means in the log form, it's also going to have base 5. Now, student, this is very important of how you write your base. Your base need to be subscript, okay? So that means it needs to be below the word log. It is not parallel to log. So if you write it this way, this would be incorrect. So log base 5. So again, your base 5 would need to be a subscript of the word log. Over, your answer is 125. So this goes here. Log base 5 over 125 equals, your exponent is 3. So it goes right there. And that's how we go from exponential form to log. Similarly to this one, your base is 49. That means it's also the base in log, right? The word log, okay, if you need to, maybe do a couple of dash like this so we know where the subscript's going to go. Your base is 49, so that's going to go log base 49 over, your answer is 7, so this is your answer. So it's going to go right there, and then it equals the exponent, whatever that may be. So that's how we go from exponential to log. All right, last one. I want you guys to try that out and then come back to me with an answer. Did you guys get log base 2 of 64 equals 6? If you did, good job. Okay. 4 to 6 says, write in exponential form, solve for x if it's possible. Okay. So now we are going to go backwards, guys. We have log form, log base 9 of 81 equals 2. Now remember, the base is still 9, so that's still going to be true. So your base goes to the answer. The answer is the exponent equals 81. And clearly, 9 to the second power is 81. So that is a true statement. Number 5 said, hey, log base x of 343 equals to 3. And again, your base is x, so that maintain a base. So we're going to go base 3 and then 2 here. Okay, so it goes from base to answer, and then, so your exponent is 3 because that's the answer in log equals 343. That's how we go from log to exponential. And it says solve if possible. So we are going to try to solve. Now to undo, guys, x to the third, we would need to take the third root. So I'm going to write that out here. To undo, so take the third root to both sides. Now, oftentimes I see students forgetting to write the index. You must write the index. So this is x equals, well, 343 students. We can break that down. If you need to, take out your calculator. 343, you know it's not an even number, so it's not divisible by 2. Now, if it's an odd number, you can add up the digits, okay? 2 plus 4, that's going to be 7. 7 plus 3, that's going to be 10. So that's not divisible by 3. But we can try perhaps 9. Okay, so 340. Well, we know it's not divided by 5, so we can try 7 and then 9. So let's try 7. So if we take it, divide by 7, that's going to give 7 and 49. 49 is 7 times 7, so it looks like we have 3 7s in there. So this is the root of 7 to the third. That will allow us to say, okay, well, cube root and and power of 3 is going to cancel each other out. So that's going to allow us to say x equals to 7. Okay, so first write it as an exponential and then solve if possible. Example 6. Similarly, let's write it in exponential form. We are going to have 6 to the power of negative 4 students equals 1 over 1,296. We don't have any variable in this question, so we do not need to solve. We're just going to leave it just like that. Examples 7 to 10 says evaluate. Okay, guys, so evaluate means we are looking for an answer. Okay, now if you are more comfortable, then you can even give it a variable. Okay, log base 3 of 81 equals x, whatever this answer is. Now if you don't like using x, you can use w or just leave a blank box. Okay, now we don't know how to solve it in log form, but we can rewrite it, guys, as an exponential. So if you choose an x variable, you're going to keep it as an x variable. Let's just all go to x. Okay, so let's write it in exponential. 3 to the x equals 81. Well, we do know 81 is 9 times 9, and 9 times 9, we can break that down to 3 to the 4th. Well, if 3 to the 4th, we already learned to drop the bases if the bases are the same. So x comes out to be 4. So students, log base 3 of 81 is 4. Okay, so log base 3 of 81 is 4. Or you can write x equals 4. One of this is totally okay. Number 8 said log base 2 of 1 over 32 students. We need to find an answer, and again, you can write it as an x equals to x, so it's easier for you to solve. Let's write it as an exponential form. 2 to the x power equals 1 over 32. Now, anytime you have 1 over something, you can always rewrite it as 32 to the negative 1 power. This will allow you guys to break down 32, okay? So 32, it's an even number, so we can start with 2 times 16. 16 is 4 times 4, hence you can see that. And a lot of you already know that 32, we have 5 2's in there, okay? So 2 to the 5th. Power to the power, students, we can multiply the exponent. So that's going to be 2 to the negative 5. Hence, the bases are exactly the same, so we can just drop those. Your answer is going to be x equals to negative 5. Now, if you don't like to use x, it's okay. Use a w, use a box, okay? So your final answer is x equals to negative 5 or just simply negative 5. So the next two example, guys, are a little bit more difficult, so make sure you guys are paying attention. Okay, so again, we have log base 7 of 7 to the 3rd power. Okay, so again, we can let this be whatever answer it is. Okay, we don't know what it is yet. So in this case, I'm going to let it be a box, an empty box. And again, you can write a variable x if you want. Similar process, guys. I'm going to start with rewriting it as an exponential equation. Okay, so this is your base. Your base is 7. So we're going to write 7. Remember, this is an answer, so that's going to be raised now as an exponent. And this right here, that's what it's going to equal to, 7 to the 3rd. Well, clearly, we have now a base of 7 on the left and a base of 7 on the right. So this box, for it to be an equivalent, an equal, would need to be 3. So our final answer, guys, is 3. Okay, so log base 7 of 7 equals 3. Oops, to the 3rd, my bad. Log base 7 of 7 to the 3rd equals 3. Now, then we can conclude, okay, moving forward, guys, if you have the base, okay, if the base is the same as this number, then the answer will always be the exponent. So for example, I want you to try this out. Log base 9 of 9 to the 4th. What is the answer? Then I want you to try log base b of b to the 11th. Give me an answer for that. And one more, log base m of m to the 7th. Okay, so 3 questions, fill in the answer. All right, example 10, let's move on over here. Now this one, this whole thing right here, guys, oops, I meant to highlight. This whole thing right here is an exponent, okay? So this is your exponent. This right here is your base. So base is 4. Now currently it is in an exponential form. The exponent just happened to have a log in it. So what we want to do is rewrite, okay, rewrite as a log. So when we rewrite as a log, we will start with the word log. Your base is 4. Remember, it has to be as a subscript, so it goes like that. Of whatever answer this is, let's give it an x. So of x, and then we're gonna say, okay, equals this right here again, okay, is what the exponent is. So we are going to keep it as an exponent. Let's use green. Okay, here's the, okay, so log base 4 of 11. Well, this is going to be a very similar process as an exponent. If you have log base 4 on the left and log base 4 on the right, then clearly x has to be 11. So students, your final answer here is 11. Okay. Well, then moving forward, okay, as you can see here, we have base 4 of log base 4. Then the answer would just be that. Okay, that in this case is 11. So I want you to try a couple of examples. What if I have 5 to the power of log base 5 over, let's say, 9? So what is the answer to that? Give me that answer really quickly, and then let's do 2 more. M to the power of log base m of 100. Okay, so give me that answer. And then one more, we can do 10, guys, to log base 10 over 95. What is that answer? All right, give me those 3. So just like exponential, students, exponentials had properties, right? Excuse me. Now logarithmics also have properties. So if we have log base b of m times n, then we have equals log base b of m plus log base b of n. So remember, guys, when we had log, or not log, sorry, in exponential form. So this is very similar to exponential, because remember, log is the inverse of exponential. So if we have, when do we add the powers? When we are multiplying, right? So if we have 5 to the x times 5, oh no, you know, let's do x to the 5th. X to the 5th times x to the 7th, right? Then we would say, okay, that's really x to the 12 because we do 5 plus 7. Well, similarly in log, right? If we have log base b of m times n, then we are going to be adding m plus n, okay? Now, in division of log base b of m divided by n, then it's going to become a subtraction problem. So that equals to log base b of m minus log base b of n. We also have power property in log. Log base b of m to, let's take this exponent, aka power, let's call it p. Then we drop down the p and make it a multiplication to log. So log base b of m to the power p equals p times log base b of m, okay? Now, be careful with this, students. You may never, ever distribute logarithms, okay? Again, you may not distribute. Examples 11 to 15 says, write as a single logarithm. with no coefficients, okay? So one single log, that means your final answer may only have one word log in it. First, this one says log base 7 of 2 plus log base 7 of 8. They're both the same basis here. So that means in addition of log, it becomes multiplication. So log base 7 of 2 times 8, which, students, equals log base 7. 2 times 8 is 16. So rewrite as a single logarithm. So final answer, we only have one word log. 12, log base 3 of 10 minus log base 3 of 5. Students, you may only use these properties if your bases are the same. So when it is a subtraction, we are going to rewrite it as one log, but then we are going to divide. Take 10 divided by 5, hence we have log base 3. 10 divided by 5 is 2, and then that allows us to have one log left. We cannot have coefficients. This is what we call the coefficient, the 3 in the front, okay? So 13 says 3 times log base 7 of 4. So the 3 is your coefficient. And you said, no, you can't have a coefficient. But remember, when we have a multiplication of log, this 3 becomes an exponent. So we can write it as an exponent. So log base 7 of 4 to the third. Well, 4 to the third, guys, is 4 times 4 times 4. So that's going to give us 64. So log base 7 of 64. 14, we have two coefficients, the 2 and the 5, and we have an addition in the middle. So first, let's just rewrite it without the coefficients. So log base 2, remember the coefficient becomes the power, okay? The 2 is kind of get lost right there. Log base 2 of x to the second plus log base 2 of y to the fifth. Because the bases are exactly the same and we have an addition, so we are going to rewrite it as a multiplication. So it's going to be x squared times y to the fifth. And we have one log with no coefficients, so we are going to pinch that in. All right, 15 says the coefficient's a half. So this is red. 1/2 times log base 6 of a minus 4 times log base 6 of b. So again, the coefficient is a half. That's going to be an exponent. Coefficient of 4, that's also going to be an exponent. So this is going to say log base 6 of a to the half power minus log base 6 of b to the fourth power. So a subtraction, students, remember, we also have to check for the bases, okay? They have to be the same. Subtraction, students, it becomes a division. So log base 6 of a to the half divided by b to the fourth. Now, it depends on how they want you to write an answer. Sometimes it doesn't want fraction, aka rational exponents. If that's the case, a half power, students, it's the same as the square root of a. So we can write it as square root of a over b to the fourth with the log base 6. So write both of those options down. Okay, so 16 to 20 says expand the logarithm without any exponents, okay? So expand meaning that we're just going to go reverse of what we just got done doing. So we have log base 5 of 3 times x, okay? So if we say 3 times x, that times allows us to do an addition. So log base 5 of 3 plus log base 5 of x. We can't go any more because we don't have any more multiplication or division or exponent. So that's as far as we can go. 17, log base 4 of 7 divided by 9. So again, division allows us to subtract. So it's going to say log base 4 of 7 minus log base 4 of 9. Okay. Next, 18 says log base 4 of x to the fifth power. So remember, an exponent here, students, will allow us to move it and make it a coefficient. So 5 times log base 4 of x, because it says without any exponent. So box that up. Ooh, okay, so log base 5 of 2 times square root of x divided by y to the third. Okay, so guys, make sure you're very cautious. First, let's take care of the division. So log base 5, if it is a division, we are going to write it as a subtraction. Okay, so log base 5 of y to the third. Now square root, students, okay, square root, that's an exponent of a half, okay? But the next step is we can't have multiplication. 2 times square root of x is going to be an addition because we just said 2 times, right? So log base 5 of 2 plus log base 5 of square root of x. And again, square root of x, we would need to rewrite that in a little bit as a power of a half. Okay, now here's the power of y. So that will get dropped down as a coefficient. I'm sorry, that's supposed to be a minus. So minus 3 times log base 5 of y. Now, what we are going to focus on is the square root. So log base 5 of 2 plus log base 5 of x to the power of a half minus 3 times log base 5 of y. This half, students, is an exponent. We will need to drop it down as a coefficient in the front, aka multiplication. So final answer, log base 5 of 2 plus half of log base 5 of x minus 3 times log base 5 of y, and box that up. Okay. All right, last question in this set. We have log base 8 of x to the third times y. So anytime we say times, students, that is immediately going to become an addition. Okay, so log base 8 of x to the third plus log base 8 of y. We cannot have any exponents, so that will need to be dropped down as a multiplication, aka coefficient. So 3 times log base 8 of x plus log base 8 of y. Now I want you guys to pay attention. Are your bases subscripts, right? So make sure that's below the word log. Box that up if it is. If it's not, correct it, please. So the change of base formula, students, is extremely important, okay? So let's start with log base b, let's call it, of m. Now sometimes we can't use base b in the case of your calculator. It doesn't have any other numerical base except base 10. So in that case, we are going to use log base 10 of m divided by log base 10 of b, okay? Now, in the calculator, if it says log base 10, students, that's the same thing as it doesn't actually have log base 10. If you don't see a base written, it's always base 10. So normally you're going to see log base m divided by log base b. Now, what if we have log base e, which we study, right? 2.718 log base b e of m divided by log base e of b. If this is the case, students, okay, so this log base 10, it will more often than not will not have a base written. So this is what we call a common base, okay? Base 10 is called a common base, meaning that you will not see it, just like square root, right? You're not going to see an index of 2. Now, next is log base e of m. Log base e of any base e, it's immediately rewritten as the natural log of m divided by the natural log of b, just like that, okay? Because e is a special number. So you are not going to see log base e, okay? Instead, natural log will be used instead. But if you see natural log, then do know that is log base e, Okay, guys. So the next 3 examples, students, you will need a calculator, okay? Our direction says use the change of base formula and a calculator, okay, both, to find an approximation value for each logarithm. So let's round to 3 decimal places, okay? Round, oops, I meant to get a pen. Round to 3 decimal places. Now, if you don't have a calculator at the moment, please pause and go get a calculator, because you do need to know how to use a calculator. Log base 4 of 22. To use the change of base formula, students, we can do it 2 ways. We can use log base 10, okay, which you are not going to see any base written because it's a common base. So we're going to write log of 22 divided by log of 4. Or natural log button, okay, remember the natural log is log base e of 22 divided by log of 4. Now, I want you to punch those both in. So figure out, students, if your calculator is going to need you to press log first, or if you look at my calculator, I'm going to show you guys really quickly. This is a built-in calculator on my computer, okay? My calculator here says I need to press the numerical first, like 22 first, and then hit log. Then it will give me a decimal approximation, okay? Then once I have that, then I'm going to hit the division button and log of 4 here. So I'm going to press division. Let's go back to my calculator. Then I'm going to press divide, and then I'm going to do open parentheses just in case I mess up. And then 4 first, and then log, and I'm going to close it, okay, and then hit enter. So here is my decimal approximation, 2.2297, okay, but I'm asking you to round it to 3 decimal places. So let's write that in really quickly. So 2.2297. So I need to look at the 4th digit. In this case is 7, so I need to round this to 2.30. Okay. Now let's go try the natural log button. So again, on my calculator, I would need to, I'm going to clear it out. Now, some calculator students, you're able to hit log and then 22, okay, and then divide log 4. But this one is a little funky where I need to press the numerical first. Okay, so I'm going to try natural log. Same thing. I'm going to hit 22, hit natural log. Okay, it's going to give you at first different decimal approximation, but divide, open parentheses, 4 natural log, close it, hit enter, and then guys is giving me the same exact answer. So notice how doesn't matter how we use the change of base, as long as the basis we are using is the same, then the answer should be the same, okay? So both are giving us exactly the same decimal approximation, which is 2.2297, which we need to round it up as 2.230, okay? Next, I want you to try these 2, okay? Feel free to use whatever you want. You can use log, okay, or you can use natural log. That's really like a personal preference here. But if you use log, then both of them need to be the same. If you use natural log, then both of them also need to be natural log here, right? Give me your 3 decimal approximation here, students, okay? Once you have that, write it in, and then last one, same process, okay? If you want to use natural log of 3 divided by natural log of 11, or if you want to press the button log, remember, log without a base, it's a common log, okay? That means log base 10. So log of 3 divided by log of 11. I'll do this last one with you. Okay, here we go. Log. Let's go clear out my calculator. Clear. log of 3. So I'll hit log. Oh, no, my calc. Oh, look at that. See, it's telling me I got no numbers yet. So 3 first and log. Then divide. Open parentheses. 11 first. Then divide. And then close it. And then enter. So I have a number that's less than 1. So in this case, it's 0.4581. Okay, so 0.4581. If we are looking at rounding at 3 decimal places, we want to look at this 4th digit. In this case is a 1. So our answer is going to be 0.458. Okay, so let's write that in. 0.458. Okay, all right.